Hello, everyone. Uh, Thank you for joining today's webinar. Today's webinar is about the visible advantage that V-Ray 3.6 for Revit adds to your BIM workflow. And today, Ana Lyubenova will provide real-life example of optimization and workflow applicability. The demo will also feature V-Ray for Revit superpowers, from the streamlined, intuitive UI to the support of V-Ray Proxy objects and the immense power boost introduced by hybrid CPU and GPU rendering. Last but not least, Ana will give you a sneak peek inside what's to come in the next update. Think real-time and interactive. Ooh, exciting. Let me tell you a little bit about Ana. Ana Lyubenova joined Chaos Group's V-Ray for Revit team in 2016, where she's responsible for product quality. She's also a working architect with over 10 years experience in Autodesk, Revit, and BIM. And now let me show you a little bit about Novedge. This is the Novedge product page where you can find V-Ray for Revit and for anything else, as you can see. And we offer a huge assortment of software solutions that cater to virtually every designer's need. Put us to the test and come visit our webpage at novedge.com. And for more daily software news and limited time promotions, you can always find the latest and the greatest on the Novedge blog and on Facebook, Google+, and Twitter. Coming up on our next Novedge webinar, Augmented Reality in Creo and Design Share. Last but not least, today's webinar is free and it's also being recorded. So if you want to rewatch this or any other webinars episode in our collection, just head on over to Novedge's YouTube or Vimeo channels. And now I'll stop my blabbering and I'll share Ana's screen. Good evening, Ana. Thanks for joining us.
Thank you, Barbara. Good evening. Can you let me know if you can see my screen and if you can hear me so that we can proceed with my presentation?
Yeah, we can see your screen and we can hear you just well. Go on, go ahead.
All right. Hi, everyone, and thank you for joining today's webinar. Once again, my name is Ana. I'm architect and I'm part of the V-Ray for Revit team here at Chaos Group. V-Ray for Revit is one of our fairly new products, as its first official version was launched about a year and a half ago. For the time we have today, I will try to show you how to fit it in your BIM workflow while taking advantage of a wide variety of features which we've introduced in version 3.6. At any point, if you have some questions, don't hesitate to send them over the webinar chat panel. And at the end of the demo, we will do a quick Q&A session. I'm starting with a short intro about V-Ray and the idea behind V-Ray for Revit. Probably some of you are aware of this. Over the years, V-Ray turned into an industry standard in the field of architecture and architectural visualization, with 92 of top 100 architecture studios in the world using it on a daily basis. Here is a list showing some of them. Some of them are already using V-Ray for Revit as well, because finally we have V-Ray integrated directly into Revit. As a Revit user, I would only say that this is great, as it saves us not only time and money, but also the struggling with other software platforms and the transition of the Revit model. V-Ray for Revit can be best described in these three words. It is easy, powerful, and fast. We know that Revit users usually work under tight deadlines and their main focus is not the visualization, yet they need it. And they need it in a way that will not consume much of their time and will not require any training, which also takes time. And it also steals part of their creative energy. In general, they need something that is easy as clicking a button. On the other hand, they need a tool that is powerful enough to express their ideas, to present them in the best possible way. V-Ray for Revit is powerful as it uses the same V-Ray engine that is used and well known in 3ds Max and Maya. Simply, some settings are optimized and hidden from the interface, again with the intention to ease the interaction, and it's fast. And here I'm not talking only about fast render times, but also about fast workflow and about settings which can be set up in a fast way. Since our topic today refers to the visible advantage, I would like to inform you that all images that you will see during my presentation were rendered in V-Ray for Revit. So let's start with what is V-Ray and the main benefits it could bring to the typical AEC workflow. And then we will continue with some real-life examples how to use V-Ray, and I will guide you through the new features in V-Ray version 3.6. V-Ray is a rendering plugin which installs as a seamless part of the Revit interface. As I mentioned it before, this means that you don't have to struggle with any other intermediate software platforms anymore and to export and reload your Revit model over and over again. Everything you need is inside of Revit. V-Ray is suitable for all stages of the design process. Depending on the situation, you can use it both for conceptual renderings as well as for highly realistic images. In any case, it can help you present your ideas in a way that is understandable for everyone. I'm sure all of us have faced the problem with clients becoming skeptic when they see a drawing as it doesn't speak much to them and they can barely visualize it. So basically this problem can be eliminated with V-Ray for Revit. It will help you convince easily your clients and your colleagues, and even in some occasions yourself as well. And respectively, it will allow you to take design decisions faster and evidently. Here is a fast concept result. Here's how it would look like rendered using the global material overrides feature in V-Ray for Revit. This feature is great for massing studies as it allows you to explore the impact of opaque and transparent materials in the masses configuration. It can be used for lighting and spatial studies as well. We will see how it works in a while. It is very easy and you can achieve this result basically in a few clicks. This type of rendering is also a starting point for creating a more realistic image, as we need to set up the lighting first without being distracted by different materials and patterns. And if we take advantage of all V-Ray for Revit features included in version 3.6, we can end up with an image like this. Or you can also render VR panoramas like that one and view them either on a desktop app or using a VR headset, and your clients will be impressed that they can dive themselves into their future house. Okay. Here are the highlights of V-Ray 3.6 for Revit release, starting with the UI, which has been cleaned up and reorganized. The material browser has been replaced by an asset browser with extended filtering and selection options, as well as new panels for V-Ray Proxies and V-Ray FUR. Proxies and FUR are entirely new features for this release. We've also improved the way settings are shared between users and projects. There are great speed improvements, including export optimizations and hybrid rendering. New light theme for the standalone material editor is now matching Revit's interface. VR scans, world's most photorealistic scanned materials, are now compatible with V-Ray for Revit. Stay with me. till the end of this demo, as I'm going to show you some exclusive things like how to convert objects to V-Ray proxies, something that hasn't been shown on previous webinars. And at the end, I'm going to unveil what is coming to V-Ray for Revit very soon. Time to jump into Revit so that I can show you how we have reorganized the UI settings to make the workflow smoother. The Revit model that I'm using was provided by our user Dmitry Kuznetsov. As I mentioned, V-Ray for Revit installs as a ribbon part of the Revit environment. Initially, the toolbar buttons are grayed out. All you need to do is click the Acquire License button to turn on the toolbar and make it active. Your V-Ray for Revit license is not engaged automatically when Revit is launched. This is very useful in many cases. In case you're a freelancer and have a working station and a laptop, you can install V-Ray for Revit on both machines and share your license across them, depending on which one you want to use it. In case you are part of an architectural studio, probably your studio has more Revit licenses than V-Ray ones. No worries, you can again install V-Ray on all machines and turn it on only on those you want to use it. If you want to skip the acquire license step, there is an obtain license on startup option, which can be found in the settings dialog in the licensing tab. If you select it, every time when you run Revit, the V-Ray license will be obtained automatically. So we already have our license obtained, and you can see that we have cleaned up all windows and slightly changed their style. But the greatest changes are in the asset browser, which we will look in detail in a while, and in the settings panel, where the tabs have been reduced to only 6. And starting from left to right, in the renderer tab, you can find some general settings and optimizations. And the most important things here that I would like to emphasize on are at the top. First, the render engine. You have this toggle button and you can switch from CPU to GPU and to select which one of both engines to perform the rendering calculations, i.e. which one of them to be used for rendering. As you might know, by having V-Ray for Revit, you get 2 render engines in one, a CPU-based and a GPU-based. The last one will do all the ray tracing on your GPU. For now, most people still render using their CPU, but the trend goes more and more towards GPU rendering. The GPUs render very fast, and people want to take advantage of that. V-Ray GPU is a production-proven renderer already used by many companies and studios. Seeing the demand on our side, we have a dedicated GPU development team. They work hard, adding more and more features from the V-Ray core code so that you guys can take advantage of those features also on V-Ray GPU. With this version of V-Ray for Revit, you can take advantage of all hardware resources that you have. Until now, production rendering was available only on your CPU. Now it can be performed on the GPU. Simply select the GPU and click render. We have also implemented hybrid rendering. This allows for using your CPU as a CUDA device. Thus, you can basically take advantage of both your CPU and GPU devices. To run hybrid rendering, you need to select the GPU first, and then in the drop-down here, you will see, well, in case you use more than one GPU, you will see a list of all your GPUs here along with the C++ CPU. So to run hybrid rendering, you need to select the C++ CPU option. And I will switch back to my presentation for a while because I want to show you a video demonstrating how, in cases you have a nice CPU, using it with hybrid rendering can decrease your render times. Okay, back to Revit. Now I will continue with, I will keep my engine to CPU. And here I want to show you also the sampler. The sampler controls the way the image is rendered, i.e. the way we will see it appearing on the screen. By default, it is set to progressive. This means that the image will be cleared progressively during rendering, while buckets will render it on small square portions named buckets. I would recommend you to keep this at progressive, as it gives more flexibility. Even if the rendering hasn't been completed yet, you can stop it at any time and you will have an image. While if you render using buckets, you will have to wait until the very last bucket is being rendered. Moving on to channels tab. If you are planning to do some compositing, select which render elements to be rendered. Another thing here is the denoiser channel. When enabled, a denoising operation will be performed once the image has been completely rendered. This removes the noise on the image and makes it smooth. If you want fast but smooth results, use low quality render preset and turn the denoiser on. In the environment tab, you can find some atmospheric effects like aerial perspective and fog, as well as the infinite ground plane, which we will look at later on. Same for paths and sharing. We will take a look at this tab later on. The swarm tab hasn't been changed. Swarm is the V-Ray distributed rendering system that allows you to render on multiple machines at once. You have the option not to use your local machine for rendering. Which basically means that you can send the render job over to the other machines and continue working using the full resources of yours. Note that to use Swarm on multiple machines, you will need a render node license for each of them. But since Swarm is also supported in V-Ray for SketchUp and V-Ray for Rhino, in case you use any of them, you can use them as render nodes. We already saw the licensing tab, so let's jump back to my presentation to see what comes next. Asset browser, no material browser anymore. It is now called asset browser. Besides materials, it now hosts proxies and for options. We have added some very nice enhancements like multiple selection and editing of items, as well as a separate filter for linked files. The global override settings have also been extended. I will start with them to show you how easy it is to render a stylized model. So after we have obtained license, the first thing that we need to do is to select which one of our Revit 3D views we would like to render. At this stage, we are ready to run an initial rendering. However, I want to look at the quality and resolution settings. In the quality drop-down, there are quality presets from draft to very high. When I set up the render settings, I always keep this to draft because it saves time. And when I decide that I have my final settings, then I switch it to high or very high. Now the resolution panel, there are three types of resolution: preset, custom, where you can type in custom resolution and crop region, which will render exactly what you see through the Revit camera. What I usually do is that I select the crop region first, then I see this resolution and I type it in right here. Now I want to render my image in a resolution that is proportional to HD, and I know that 900 by 506 is proportional to HD, so I will set it to these values and I'm ready to run a render. I have two options, production or interactive. Production will generate a still image, while interactive will update the image progressively while we change some of the settings like materials, camera, and so on. We will see exactly how this works. I will run an interactive rendering now. So initially the model comes with its Revit assets. What I see is that the house has some generic materials assigned to it, and I would like to render my model to look like a mockup. So I will go to the Global Materials tab and I will enable the 3 override options that will override all opaque material with just one, all transparent materials, and the RPC material. Okay, now I will change the transparent material from color to V-Ray material, and I will select a material from the default V-Ray for Revit library. Now I see that the RPC color is too bright, and I will make it darker. Now, since there are some docks in front of this villa, it probably lies on water. So to create water, I will use the infinite ground plane. This option creates an infinite plane that is locked to the 0 level of the project. We can control the height based on the 0 level of the project. So I will set it to -20 and let's see how it will look like. Probably -30 would be better. Okay, and I can change the color again to something more bluish. I will make it reflective as possible, and I can go to the advanced options for the color and I can change the tint. Just like this. And now I can render the image in higher resolution, and basically my mockup model is ready, as you can see, just in a few clicks. And now the next thing that I will do is that I want to change the lighting. Currently we are using the sun, the default sun from Revit, but I want to use a dome light. Dome light is a V-Ray setting that creates an imaginary dome above the entire model. And this dome emits light with a specific intensity that you can control. And it can emit either color or an image. So I will set it to an HDR image. There is a default image which I would like to change. And I will change it with another image that I have. Sometimes we need to wait until the image is mapped to the dome light. And here you can control the rotation of the image, and basically this will allow you to control the direction where the light comes, because the light that the dome will emit is based on the image that you use. I know that with 110 it will work okay for me in this case, like this. Now I will go back to my presentation to see what comes next. V-Ray settings can be shared across users and computers. This is quite similar to transfer project standards in Revit. This is how it looks in the UI. The V-Ray settings are organized into 6 categories. Using the checkboxes, we can export or load either a specific category or all of them. This allows for creating and sharing settings templates for specific V-Ray settings, for example, a material template. So what I will do now with my Revit model is that I will import material settings so that we have materials. I have set up them on my other computer, and now I want to use them on this one. So I will stop the rendering and I will go to settings, paths and sharing. And here you can also configure paths to assets in case you have moved your assets folder to another location. You don't need to remap anything. You just need to add the path to the new location here using the add button. And this is super useful in case you work on more than one computers or if you share work with your colleagues. So now I want to import material, environment, and camera settings, and proxies. I will click load. And here are my settings. As you can see, they will be imported into categories again. We have material map and there are 36 items there. I will unmark some of them. Okay, and I will import them. In case you import an XML file with settings and you figure out that it is the wrong file and you want to switch to another one, you can click the clear list button. This will clear the import list and you will be able to reload another file. I will click import. Okay, and let's render again to see what we have. Seems much better now, but the first thing that I notice is that the dock appears white, and this is something strange in my case. The docks are a Revit link, they're linked project, You can see it here. So what I will do now is that I will go to the asset browser, and in the material map tab under filter, we have only the doc RVT project. When I select it, I can see only the materials that are defined into this particular project. So now I will drag and drop some materials there, and I can select multiple materials, and I can drag and drop a V-Ray material over them, and they will change. Okay. So no matter how many linked projects you have, you will find all of them in the list here. You can filter, you can override materials from the linked project separately from the host project, which is very useful and is not available in Revit itself. Now, back to the presentation for a while. Where it's time for V-Ray proxies. They're one of the most wanted features in this release. They allow for rendering high-resolution entourage models like trees, cars, people, and everything that comes to your mind. They import complex geometry from external meshes at render time only. The geometry is not visible in the Revit project and does not use up any resources. Currently, we are unable to load proxies directly into Revit the way it is in V-Ray for SketchUp, for example. Therefore, you need to have RPCs in the scene because they serve as stand-ins for proxies and they're overridden at render time. With the help of the Poly to VR Mesh tool, which comes along with the V-Ray for Revit installation, you can turn any high poly model into a VR Mesh file, which is the file format used by V-Ray proxies. Most users experience some difficulties at the beginning as the tool is command line based, and now I will show you how to run it and how easy it is actually to use it. Back to Revit. Probably we won't need this right now. Okay. Here I have an OBJ file, and I took a screenshot how it looks like when opened in 3ds Max. So the final result that we will have will be a tree like this. And now we need to go to the V-Ray for Revit location, which is on your C drive, Program Files, Scales Group V-Ray, V-Ray for Revit. And in the Tools folder, we have the Poly to VR Mesh tool. But if you double click on it, nothing will happen. You need to go here at the address bar and open a command prompt. For those of you who don't know how to load a command prompt, you need to type in CMD and click enter. And here it is. Now, here you need to write Poly to VR Mesh, then space, and then take the OBJ file and drag and drop it over. And what I usually do, because first you need to indicate the obj or the file that you want to convert into VRMesh. Then you need to click space and you need to type in the desired location where the converted VRMesh file will be saved. And I usually drag and drop this once again, and I just change the name at the end like this. And when I click enter, the obj tree will be saved. The VRMesh tree will be saved to the same location where the obj is. We are ready, and the tree is here. Now, back to my rendering. I will open the asset browser and I will go to the RPC proxies tab. So here you have a list of all RPCs that are loaded in the project, and the ones that are already used in the model can be filtered with the project filter. And if you select an RPC on the model, like I will click on this tree, this will activate the filter here, and you will be able to see only that tree into the RPC list, and this will it will be easier to find it. So I will just drag and drop the VRMesh here, and initially this is what happens. It shouldn't worry you if the VRMesh appears to be overscaled. This is absolutely normal because proxies are exported from different software platforms with different units and coordinate systems. That's why they might appear overscaled, and in our case also their vertical axis has become horizontal, and in order to straighten them I will use the flip axis option, and we now have the trees. You can also use the rotation slider to rotate the proxies all around their vertical axis. So in my case, I have only one tree, but in cases where you have, for example, a few RPC trees and you decide to override them with the same VRMesh, you can change the rotation of all trees to a different value and to create kind of diversity. The materials. So the proxies initially come in colors. Those colors represent their material IDs. So I will now assign V-Ray materials to them via drag and drop. Okay, and I will stop the rendering for a while because I think in my presentation now it's time for V-Ray fur. V-Ray fur allows for rendering realistic grass as well as any kind of fluffy and shaggy objects like carpets, cushions, blankets, and so on. This makes it a universal tool which can be used to add detail both in exterior as well as in interior shots. And I have a separate scene to show you how V-Ray grass works. here it is. It is a close-up view of a grass field, and I can render it. Sometimes if you assign grass to bigger geometry, like in my case, you will have to wait for it for a while. All right, here we are. Now in the asset browser, we have the V-Ray tab, where you have a list of all materials. In the current project, I have only 2 materials, but this tab is almost the same like the material map tab. You have a list of all materials that are defined in the Revit project, and you need to select the material that you want to assign fur or grass to, and simply enable it with this checkbox. And here you can see the grass parameters. Most of them are self-explanatory, like the strands per square meter, or this is the density, length, and thickness. I will now enable the render region so that we can render a smaller area, and I hope this will be faster. So first we have the density, length, and thickness parameters, and their values are related to Revit's project units. Thus, changing the units in Revit would change the units of these 3 parameters as well. And on the right-hand side, we have the corresponding variance parameters. These parameters will shuffle the strands, will make them diverse. We know that in reality they are not equal by length, thickness, or direction. So these parameters help for adding more realism. I can now decrease the density to, for example, 500, so that we can clearly see the strands. For some reason, it won't render. Well, such things happen. Let's try if we disable the region and enable it again. And if this doesn't help us, I will have to restart the rendering, but these are the risks of the live demo.
That's cool, Anna. That happens all the time. Do you want to take a questions while we wait for the rendering?
Well, if questions are related to the things that I already showed, probably I can handle them right now.
Okay, so
Yeah.
the one question, just will Revit affect the Revit standard objects like trees, or do you have to import some special objects?
No, RPCs that come along with Revit's installation are okay. They will be replaced only at render time. You can use them, you can duplicate them to create more variations and so on.
Okay, cool. All right. I don't want to distract you more than uh, I need to. So, do you need some time to figure out? Do you have to restart the render or
I just
you did?
restarted the
Yeah,
render
I thought.
and now I'm waiting for it.
Okay.
You
So maybe
can
I'll ask
see
you
it
another
right here.
question.
Yeah, okay.
How can you put grass texture to the same plane? I don't understand this question, but maybe you do.
Grass texture to the same plane.
Mm-hmm.
So to assign grass to a geometry in Revit, you need to specify a unique material for this object you want to assign grass to, because grass is associated with materials. So for example, if you have a carpet geometry and you want to make it fluffy and to add fur to it, you need to create a unique Revit material, I mean with a unique name, and that you know that this material is assigned only to the carpet, and then find it in the fur tab in the list here and enable fur for this material. And that's it.
Okay, cool.
I hope this
Great.
answers the question.
I hope so too. We'll find out. Scott, let us know if that's what you meant. And can you actually, that was a question from Pedro. But Scott is asking, can you use Vismat files or convert them to VRMAT files?
Well, Vismat is a slightly outdated file format. You can open it with the V-Ray standalone material editor and you can resave it so that it will turn into a VRMAT, but I cannot guarantee that it will render correctly.
Okay, so
Some,
converting
some
is the way to go,
Yeah,
basically.
some Vismats would work, but other ones would produce strange results.
Okay. And can you still cloud render with V-Ray?
Yes, and this is something that I will explain later on in my presentation.
Great. So we're looking forward to that moment. Stick around.
Yeah.
And we're,
Okay,
yeah,
so we are back with my
yes.
grass rendering. So very fast, I will try to go over the parameters because as I already explained, I have a huge area here and I have assigned grass to the entire area, which is not good and you have to avoid it. Grass is to add detail to your images, so it is better to assign it to a small portion of the image, the one that will be closer to the camera and the one that the camera will see detail into it, because here in the background, I don't need such detail. So what I can do is that either I can split the geometry into two parts and to assign fur only to the front one, or I can use the level of detail parameter, which is used in cases where we need to generate a large area of fur, just like this grass field. It conserves memory by decreasing the detail at areas that are far away from the camera, where we basically don't need to have detail. So we need to set up a start distance, which is measured from the camera. In my case, at 4 meters from the camera, the level of detail will be applied, and it will be applied at a certain ratio, which is specified by the rate parameter. In our case, this means that on every 4 meters, the density will be decreased 2 times and the thickness will be 3 times, and the thickness will be increased 3 times. So I already mentioned the variance parameters that they create variance around the first strands. Taper, we'll add taper to each individual strand. The bend of the strands is controlled by the gravity and bend parameters. And the knots control the smooth appearance of the strands. For example, if I set the knots to 2, the strands will be rendered into 2 connected segments, and they will look like this. They're not smooth at all. They're like needles. So if you want them to be smooth, you need to keep the knots parameter to a higher level, like 5. Okay, I think this is enough for the grass. I will stop the rendering and I will go back to the project. I will render again. If there are some questions, I can answer while we wait for the rendering.
That was that's it for now. The one about the cloud render that you're gonna take a little bit later, but so far you answer all of the questions.
Great. So now I will go to the third tab and type in grass. Okay, so in this project here we have more materials, and you can see how the material list in the third tab looks like when there are many materials. And in the filter I will type in grass. And actually I have already enabled the grass parameters, so we are now rendering with grass enabled. And what I see that is missing from my image are some rocks that were created again with RPCs that were replaced with VRMesh. They're right here, so I will have to stop the rendering again, and I will have to change the current view to camera 1 and render again. Okay, there they are. Here's how they look on the Revit view. They're just some RPCs representing some bushes, but I have replaced them with some stones that I converted into VRMesh. And we are almost ready with our rendering. However, our image still needs some enhancements, and they can be added after the image has been rendered using the color corrections panel on the VFB. Instead of saving the image and opening it in another application to fine-tune it, you can do it all inside the frame buffer. Besides, you can, after you set up the color corrections, you can save them as a preset, and later on you can load them. I can just demonstrate you how to load color corrections. They're the same that I already used, but that's it. Just browse for them and load them. And once we're happy with our image, I can now stop the rendering. There is this tiny button here That allows you to copy the current channel to clipboard, and then you can paste it anywhere you want. Name it an email or Photoshop or, I don't know, your Facebook, anywhere you want. And also, there is a history panel, which is accessible from this button here, where you can keep history of your rendered images, and you can save and compare images. So here I can find my image rendered in HD. Or probably it is in another location. This is how you can select a folder for your history settings, and the V-Ray images will be kept there. So we can load this one. Here it is. Now I will return to my presentation. And here are the scene export optimizations. This is something that we introduced also in version 3.6, and it is something under the hood, yet very important. We have optimized the way Revit geometries are translated to V-Ray by implementing a smart caching technology. This resulted in up to 4 times faster scene translation and 1.5 times faster rendering. How did we measure this? Here in our team, we have a large archive of Revit projects of different scale, and every night they are rendered with V-Ray, and our system compares their render times. We have scenes that behave even faster than the numbers that I'm giving you, but on average, this is the expected result. To unveil it a little bit more, this can be noticed when rendering complex scenes with iterative objects like curtain walls. Let's say you have a model with a large number of instances, i.e. an element has been copied multiple times. Instead of exporting all instances, V-Ray is now able to take just one of them and multiply it, and thus reducing export times. And this can be best seen on the following side-by-side comparison. On the right-hand side, we have V-Ray 3.6. And in this case, it appears to be more than 2 times faster. What comes next is the material editor. It now has this nice light theme to match Revit's interface, as well as some other UI improvements. For example, the textures are now grouped into 5 categories: general purpose, utility, 2D, 3D, and ray traced textures. The new texture maps that were added are part of the general purpose category, which means that they can be used in many different situations, depending on what you want to render. Now, back to Revit, and I will open the material editor. Okay. And here is the gradient map. You can use it to create different types of gradients. There are a few presets that you can start from, like black and white, RGB, spectrum, or you can create your own. The type parameter controls the direction and the shape of the gradient. It can be horizontal or vertical or diagonal, and some other types. The interpolation defines the color transition. It is set to, if If it is set to none, there will be no gradation between colors, and basically this would create some stripes. You can add as many color points as you want here. Left click adds a point and the right click will remove it. If you click on any of the gradient points, you can change its color from the color box right here. And as you can see, there is also a new and improved color picker where you can select colors. You can see what the previous color was and what the current one is. You can save them as presets here and so on. Now, the other texture that I would like to show you is the temperature map. And here I have a video that I will play. Usually this map is used for light sources. Real-world light sources have a specific color temperature value which affects the color of light they emit and is measured in kelvins. With the temperature map, we can specify the exact Kelvin temperature and render accurate and realistic light sources. Here we have this emissive material where the temperature texture is assigned to the emissive color slot, and if we open it, we will see that the mode is currently set to color, but we are interested in the temperature mode. As you can see, you can change the Kelvin temperature to some warmer values, and the lights will change their color accordingly. We can also increase the color multiplier, which will result in brighter light. You can experiment with the settings until you get the desired result. Now, let's move on. V-Ray for Revit is compatible with VRScan's materials. These are our ready-to-use photorealistic scanned materials. We scan them using a scanner. It takes hundreds of images of an existing real-world object from different angles and directions to capture the texture information, dimensions, and the most important thing, the unique way how the material reacts to light. This will guarantee that the material will behave like it should under all kinds of lighting conditions, and you will render out-of-the-box photoreal images. All materials are seamlessly tileable, and our current library contains over 650 scanned materials, and they're as easy as drag and drop. They're available for download on our website. You need to go to the download section. Okay, and there is a separate section for VR scans under downloads. There are plenty of materials, and you can search by different criteria like type, color, manufacturer, tags, and so on. For the next scene that I have prepared, I will need wood. We can take a closer look at it. It looks very realistic. Simply click download. And I will go back because I will need fabric as well. And I will need it in a gray color. that one. Also very realistic. And I will download it as well. Now, if I go back to Revit, I have VR scans scene. I have this very simple scene. The chair is an RPC that was being replaced with a VR mesh again. So I will render interactive. And if I select the chair, it appears on the list here. It appears in color because, as we said, the VR mesh initially appears in colors representing its material IDs. And now I will go to my VR scans. And I will just drag and drop them. And I can adjust their map sizes just the same way like V-Ray materials. Change the width and height and the rotation. Here's my rendering, and I can load another color correction file, which I have for this project. Here we are. I have also rendered the image in advance. So here you can see how it looks like when rendered in high res. Okay. Back to my presentation. As promised, coming soon to V-Ray for Revit is V-Ray Cloud. Chaos Group's new cloud rendering service is currently open and is calling for beta testers. To be among the first to try it, you can apply for access by simply clicking the cloud rendering button, which is available from the V-Ray for Revit interface, or you can visit chaosgroup.com/cloud. And now, sneak peek at what's coming as promised. Starting with Revit 2019 support, an exciting new feature is about to come: support for Revit geometry updates during interactive rendering mode. This means that you will be able to create, modify, or delete Revit geometry and see the render updating accordingly. We have updated the resolution settings as well, added some enhancements to sun and camera settings, and more is about to come. Just stay tuned. And now I will play a video demonstrating the interactive geometry updates.
Anna, this is so cool. And this is for Revit 2019, right?
Yes,
Oh,
this will
wow.
come with our next release where we will support Revit 2019.
Fantastic.
Oops. And we are almost at the end of this demo. In less than 1 hour, we explored so many things together. Let's summarize them. With a powerful V-Ray core and a simple UI, V-Ray 3.6 for Revit contributes to a better user experience. When it comes to speed, we saw that it's not only about rendering speed, but also about streamlined tools that allow you to set up a rendering in a fast and intuitive way without wasting too much time, navigate around materials without getting lost anymore, override multiple materials at once, and share work with your colleagues or clients on the go. We also saw that you can set up a rendering depending on the design stage you are currently working on. You can render concept models as well as highly detailed photorealistic images like the one we currently see. You can add detail to your images using V-Ray Proxies and V-Ray Fur, or boost them using different effects, color corrections, and other tools. You can take advantage of all hardware resources that you have, bring your renders to the next level with the VR scans compatibility, or save time rendering in the cloud. And currently, as a special offer, we have the V-Ray 3.6 trial available for all users who have previously downloaded a trial of V-Ray 3 for Revit. And if you already have a license for V-Ray 3, then you can simply update to V-Ray 3.6 for free. The build is available on the download section of our website. Everything you need to get up and running with V-Ray can be found on our resource hub, chaosgroup.com/resources. Make sure you check it out regularly because we update it regularly. Make sure you're up to date with what's new by visiting our official website as well. It is chaosgroup.com. Our help documentation can be found at docs.chaosgroup.com. To learn more about V-Ray, subscribe to our YouTube channel, Chaos Group TV. You can also join our forum to share tips and tricks with like-minded professionals. We value your feedback and it is welcome anytime. If you found this webinar useful and interesting, don't forget to spread around the V-Ray for Revit knowledge by sharing it with your colleagues and friends. And now let's switch back to Barbara.
Yes, thank you so much. Well said. Let's break the internet, shall we? With this
Sure.
webinar. Let's do it. I think that I love the presentation. I hate to take back the screen, but I just want to say that I loved your examples applied to the real Revit workflow. Thank you very much, Anna. And I want,
Thank you.
yes, I want to remind everyone to visit our page at novedge.com, where you can find the entire line of V-Ray, including V-Ray for Revit and what else? Revit. So, and if you also want to speed even more your workflow, we also have CAD workstation for the first time, and they're really customized, not just for Revit user, they're customized for you. So give us a call and we'll make it happen the fastest piece of hardware you will ever have. And let me see if I can see if there's any more question. I don't want to. Okay, now just great feedback and lots of thank yous. Thank you guys for joining us today. And I'm recording the webinar, so you'll find it on YouTube and Vimeo, where it will go viral and break the internet. And thanks again for joining us today. Have a great day, everybody. Bye bye.